Welcome to today's paper reading. Today's paper is titled, Agent Lumos, Unified and Modular Training for Open Source Language Agents. This paper, presented at the ACL 2024 main conference, introduces Agent Lumos, a unified and modular training framework for open source language agents. The authors, including Faeze Brahman and colleagues from the Allen Institute for AI, UCLA, and the University of Washington, propose Lumos as a solution to the limitations of closed-source agents in terms of affordability, transparency, and reproducibility. The abstract highlights the issues associated with closed-source agents, including their lack of affordability, transparency, and reproducibility, especially in complex interactive tasks. This has motivated the development of open-source alternatives. The paper introduces Lumos, one of the first frameworks for training open-source large language model, LLM-based agents. Lumos features a modular and unified architecture, which includes a planning module for high-level subgoal generation and a grounding module for translating these into actions using various tools. The design of Lumos allows for modular upgrades and wider applicability to diverse interactive tasks. The paper also reports that Lumos excels in performance, outperforming multiple larger open-source agents on held-out datasets, surpassing GPT agents on question answering and web tasks, and effectively generalizing to unseen tasks. Language agents are designed to execute actions and interact with external tools or environments to achieve specific goals. They have become crucial elements in AI systems aimed at solving complex interactive tasks. These tasks often require agents to perform long-horizon planning and interactive reasoning, ranging from question answering to web tasks, math, and multimodal reasoning. In this paper, we introduce Lumos, a generalizable language agent framework via unified, modular, and open-source training. Lumos employs a unified and modular architecture that is broadly applicable to complex interactive tasks, including a planning module, a grounding module, and an execution module. The framework allows for easy module upgrades to enhance new task planning, novel action grounding, and supplementing new tools without impacting others. Lumos is designed to be affordable, transparent, easy to update, and reproducible, addressing the limitations of closed-source LLM-based agents. Figure 1 illustrates the Lumos framework, a unified and modular training approach for open-source language agents. This framework facilitates effective generalization across various tasks and is designed to be easily updated. It notably offers advantages in affordability, transparency, and reproducibility compared to closed-source agents. Figure 2 provides an overview of the Lumos framework, detailing its training with 56,000 high-quality annotations. The framework introduces two key formulations for agent training and inference: Lumos-O, which facilitates efficient one-pass inference, and Lumos-I, designed for adaptive planning that adjusts based on execution feedback. The figure illustrates practical examples of Lumos-I in action, specifically within the AOKVQA and Mind2 web tasks, showcasing its flexibility and effectiveness in handling complex interactive tasks. The Lumos framework consists of three main modules: the planning module, PM, which breaks down complex tasks into subgoals, the grounding module, GM, which translates these subgoals into executable actions, and the execution module, EM, which implements these actions. Two formulations are proposed for this framework: Lumos One-Pass, Lumos-O, and Lumos Iterative, Lumos-I. Lumos-O generates all subgoals and actions in one pass, ensuring efficiency, while Lumos-I generates one subgoal and its actions per iteration, using previous execution results to adapt to environmental changes. Both methods enhance the interaction and communication among the modules. The authors fine-tune planning and grounding modules using high-quality tasks, subgoals, and low-level actions. They employ LLMs as a style transfer tool to convert existing benchmarks into the Lumos format. This involves using 4-5 shot examples and conversion prompts, defining action interfaces, and providing ground truth intermediate reasoning steps. The annotations are organized into a conversational format, where the user provides tasks and execution results, and the model responds with subgoals and actions. During training, The authors use a decoder-only model with binary masking on user prompt tokens to focus the loss on ground truth responses, enhancing the model's adaptability to environmental changes. The experimental setup for Lumos involves converting annotations using GPT-4 and training planning and grounding modules with Llama 2 models. Action interfaces are integrated to handle interactive tasks. In evaluating Lumos, the focus is on its performance across various complex interactive tasks such as QA, web, math, and multimodal tasks. This evaluation follows established settings from Agent Bench and ReWO, with a particular emphasis on the model's performance on held-out datasets to assess generalizability. Additionally, Lumos is tested on unseen tasks like Web Shop and Intercode SQL, where it demonstrates the ability to adapt and generalize effectively using few-shot learning examples. Table 1 presents the performance metrics of various language agents across different complex interactive tasks. It highlights that GPT-4 achieves a higher stepwise success rate in web tasks compared to GPT 3.5 Turbo. The Lumos iWeb 13b model demonstrates substantial enhancements over other open-source agents in web tasks, as indicated by the marked performance scores. Additionally, the Lumos IAL 13b agent, trained with combined annotations, shows superior performance in handling unseen tasks such as Web Shop and Intercode SQL, reflecting its strong generalizability. Table 2 compares the performance of 7B-sized agents trained with different annotations. It highlights that Lumos data, which includes high-level subgoals, yields better results on strategy QA and hotpot QA compared to ReWO open data. The table also shows that using low-level subgoals instead of high-level ones results in a performance drop on QA datasets, reinforcing the effectiveness of high-level subgoals. Additionally, integrating Lumos annotations with general instruction tuning data like Alpaca allows Lumos to achieve a Rouge-L score close to that of Llama 2-7b, indicating its capability in both agent reasoning and general instruction following. In the realm of language model, LLM, agents, React introduced a prompting method to shape LLMs as language agents and ground them in external environments. Subsequent methods have aimed to improve agent performance and applicability in diverse scenarios. However, these agents primarily rely on closed-source LLMs, which raises concerns about affordability, reproducibility, and transparency. Recent works have focused on utilizing larger models to generate training data for fine-tuning smaller models, enabling them to follow instructions and perform chain-of-thoughts reasoning. Contemporaneous efforts like ReWO Open, FireAct, and AgentLM concentrate on training agents on smaller LLMs. Unlike these efforts, our work aims for a more in-depth analysis, seeking a unified task representation to enable agents to generalize across unseen interactive tasks effectively. Table 3 provides a detailed comparison of various training formulations for language agents, focusing on their performance metrics. The primary metric used for evaluation is the LLM accuracy percentage on the hotpot QA dataset. All experiments detailed in the table are conducted using the Llama 2-7b model. The comparison highlights the differences between integrated training and chain-of-thought (COT) training approaches across different task types, including web tasks, math tasks, QA tasks, and multimodal tasks. This table is crucial for understanding the effectiveness of different training strategies and enhancing the performance of language agents. The Lumos framework is an open-source, generalizable language agent training framework. It introduces two formulations, Lumos I and Lumos O, which enhance collaboration among agent modules to solve complex tasks. Lumos has demonstrated superior performance, outperforming various open-source agents across 9 datasets, and even surpassing GPT agents in QA and web tasks. However, there are limitations. Lumos is currently trained on annotations for 4 specific types of complex interactive tasks, which may limit its generalization capabilities for novel tasks. Additionally, it lacks sophisticated self-corrective features for backtracking and replanning. For part of the QA experiments, Lumos relies on GPT models, which is designed for fair comparison but is a partial reliance on proprietary tools. Future work aims to address these limitations by expanding the training data to include a wider variety of task types, enhancing the framework with advanced self-corrective mechanisms, and transitioning to fully open-source QA frameworks. Thank you for watching.